So welcome back after the break. Next, presenting, we have Patricia Corcoran, who is a professor of earth sciences at the University of Western Ontario in Canada. And over the past 2 decades, Patricia's research has focused on natural and anthropogenic sedimentary deposits, with particular emphasis on macro and microplastic debris pollution and its potential to become part of the future rock record. So today she's going to talk to us about tumbled, rolled, and buried plastic debris incorporated into shoreline grasses.
Thank you, Catherine, and thank you for inviting me. The talks that I've heard thus far are amazing, and I'm really interested in all of this kind of work that deals with the Anthropocene. It's a little bit early here. It's 7:15 a.m., so I'm still waking up. I just wanted to apologize very quickly to the speaker right after me. I'm going to have to jump out and drive my son to school, but otherwise I'll be back. So yeah, I am going to talk to you today about a little pet project of mine. I think that what I'm talking about is very familiar to any of you in the UK or even around the Mediterranean. And I'm going to go to my next slide. Does that? Yeah. And really what I'm talking about are these, sorry, I need to change the view. Okay. Are these balls on beaches. And I got excited about these because I had never seen them before, coming from the middle of Canada, where we have the Great Lakes, but we don't have an ocean unless you want to drive a few days to the west coast or a couple of days to the east coast. So they've been called numerous things: sea balls, Neptune balls, whale burps, all kinds of things, even fuzzy balls. And my questions were, how do they form? Why aren't they everywhere? Why are they of different shapes? Why does packing vary? What's inside them? How much plastic debris do they scavenge? And what is their fate in the sedimentary record? And so there is a scientific publication out by Sanchez Vidal et al. In 2021, in which they report that they found up to 1,470 plastic items per kilogram of plant material. And so the sizes of those plastic items range from 0.55 to 287 millimeters. And so I was thinking that some of these are microplastics, but not all of them. And actually the majority could be considered macroplastics as opposed to micro. But it was in the media quite a bit. So the Guardian said plastic debris in half of the loose seagrass is 600 bits per kilogram, very scientific. Only 17% of the seagrass contained plastic, and that's the tightly bound type. And so I wanted to collect these balls from beaches that were freshwater as well as marine and compare them. And I like this quote here from the World Economic Forum. Almost 900 million plastic particles a year are being trapped by seagrass Neptune balls, which I don't know how they got that number, but it's always interesting when things like that appear in the media. All right, so one of the things that was in that scientific publication was that the balls are forming in shallow water in the surf, and that the grasses themselves are growing in the water. Well, what we have here in Canada is a bit different. What we find in the Great Lakes is that as the lake levels rise, the waves erode the dunes, and the native grasses on the dunes are pulled into the surf, and they mingle with other objects, including sand and other organic debris and plastic. When the lake levels falls, the bundles are left on the beach. So that's another hypothesis. So what I found in doing research thus far is that nobody really agrees on how these balls form in different locations. So is it waves? Is it the surf? Is it wind? Before I read anything, I actually thought that these balls were forming as they're tumbling across the beach surface. So the objectives of this project are to classify classify the balls using, and I have nothing there, but sedimentological methods determine microplastic abundances and sizes, determine their types, and search for correlations between the microplastics and location, water type, grass type, size, shape, and packing, anything that you could imagine, because I am so curious about these balls. And then finally, assess the possibility of their burial and preservation. So these are just the 3 locations that I chose to sample. So one of them is, so these are the Great Lakes, the Laurentian Great Lakes of North America. They hold 21% of the surface water of Earth. So you can see the scale bar here is 100 kilometers. So one beach here is called Shunia Beach, and that's on Lake Superior. Another beach here is called Ipperwash Beach on Lake Huron. And then I also sampled some of the I'm just going to call them balls because I haven't yet decided what to call them, but I also sampled the balls on Is Arenas on the island of Sardinia. And so the difference is, of course, this is a marine beach. These are freshwater beaches. All right, so just quickly, on Is Arenas, commonly we find the Posidonia oceanica balls, which everyone's so familiar with. And so I'm sure many of you have seen this if you've been to any of the coasts in the Mediterranean. These balls typically form, true enough, in the surf with this type of grass which actually grows in the water. And so yes, they are initially formed there, but I'm curious to know if they are also, if more microplastics and more material is being added to them as they're moving across the beach surface with wind. So we collected a bunch of these, and this just shows the different types of shapes that were there. So we used Zing's 1935 shape classification. So we've got things that look like they're oblate, prolate, some are equant, some are perfect balls, and others look like footballs. And then basically this is what they're forming from. A lot of this is the rhizome part of the seagrass itself. And as you can see, there is some plastic, of course, intermingled with these balls. Okay, that's not moving that forward. There we go. Okay, so then on Ipperwash Beach, this is Lake Huron, what you see here. And if we look along the shoreline, along the strand line, you can find these balls as well. The really cool thing here is that when I would see these little hairs sticking up from the beach surface, if I dug them out, this is what I would find. So a lot of them are already buried beneath the surface. And I don't know if you can tell from this image, but the Ipperwash balls, which are made of Ammophila, so the marram grass, a different type of grass on the Great Lakes, tend to have visible plastic in the balls, whereas what I found on Is Arenas, you can't really see the plastic from the outside of the balls. Interestingly enough, the Ammophila is typically found on the North Atlantic, but the Great Lakes are one exception, and a freshwater exception of where we can find them. And then our third beach is in a place called Shunia. I've been there twice, and the first time I was there, this is what it looked like. The water was very high. 6 years later, this is what it looked like. So the first time around, I didn't find any balls. I wasn't looking for them, didn't see them. And the second time around, I did find them within the strand line only. And that's just gives you an idea of what they look like. So these ones were not as densely packed as the balls in the other locations. Okay, so our methods, we disassembled the balls in diluted 30% hydrogen peroxide, placed them in the oven. Then we added Fenton's reagent and digested for another hour. The samples were then hand sieved, and residue from each of these grain sizes was kept in different petri dishes. They were dried, and then the greater than 5 millimeter fraction was visually examined, and the less than 5 millimeter fraction was microscopically examined for microplastics. So results to date, we just started this. So Bear in mind that there are only 13 samples that we've analyzed thus far. It takes longer than we thought to digest the grasses, but we have about 60 to 70 samples that we're working with. And so for Isarenas, you will see here that for most of the samples, the amount of fibers and fragments in terms of microplastics are pretty even, except for 2 of the samples which have quite a number of microplastic particles, and especially fibers in these 2 samples. If we look at Ipperwash, then what you would see here is that it's mostly fibers, and there is a lower amount of microplastics in the Ipperwash samples than in the 2 samples in Isarenas. But if we go to greater than 5 millimeter plastics, you'll note a really big difference. So Isarenas, only 1 sample had fibers, and in the Ipperwash samples, all of them contained fibers or fiber bundles. So there were quite a lot of plastics, again, that you could see, and not so much on the Sardinian beach. And then, of course, we only have 13 samples, so our p-values are not very good, nor is our R-squared value, but I just wanted to give you an idea of what we found thus far. Thus far, most of the microplastics are in an equant shape, then prolate, then oblate. If we think about the mass, we tried that, measuring the mass versus the number of MPs, not a very good correlation at all. So we're hoping maybe something will be different once we analyze all of them. And then we also did what we called relative packing category. We did that by site. So we have a category 1 in which it's not really packed at all. It's just loose things. And then 2 mildly, and then 3 moderately packed, and then 4 was very well packed. So the very well packed bundles, I'm going to call them, tended to contain the highest number of MPs, which sort of makes sense intuitively. But we're really interested in what we're going to come up with next. And then I want to talk a little bit, just a few minutes, about burial. And so what are the chances of these being buried? What I found on 2 of the beaches, and I don't have results for Shunia yet, by the way, but on 2 of the beaches, I noticed that, on the beach surface, the strand line, and this was Isarenas, you can see a multitude of balls. It's 100% coverage. But as you move back to the back beach toward the dunes, you start to see that some of these balls are not as densely packed, obviously, but also that they start to become buried. And as you move between the dunes more back, you will find that most of the balls are buried. So they are becoming buried. Now, whether they become preserved is another question. So the balls themselves, obviously, because they're mainly organic, will not be preserved, but the plastic will be preserved because it is being buried with the balls. And so just quickly, conclusions. We found up to 41,304 microplastics per kilogram of dry weight of grassy bundle material. The other study found about 1,400 MPs, but again, they weren't looking at the finer grain size. They weren't looking for microplastics. And then we had between 4 and 110 MPs per bundle. And we also found there was much more plastic debris in the greater than 5 millimeter range in bundles from Ipperwash, higher average microplastic abundance in bundles from Isarenas, 12,550 per kilogram of dry weight. And we also found differences in bundle packing and shape. So the packing for Isarenas was much greater than the packing for the freshwater Great Lakes beaches. And also there is a greater variety in shape for Isarenas than there is for Ipperwash Beach. Also, we have different grasses that are making up the balls. And that leads us to ask the question, are there different processes going on? So again, the bundles won't be preserved, but their burial ensures that the microplastics have great potential to be preserved in the future sedimentary record. Maybe one day we'll see aeolianites and we'll find, well, not us, but our descendants will find aeolianites in the rock record and find these plastic particles within them. Thank you.